We are continuing with the previous MQTT session. So we have seen MQTT message format with all these fields. We discussed all these fields, and we have highlighted with the message type, as we are saying that there are 14 types of messages and QoS, three levels of QoS, quality of service. We'll see that message type and QoS fields of this MQTT message format. With respect to the message types, we have 14. Please look into this particular table. We are clearly identified and differentiated between each message types. So we'll just follow the value in that particular field. We'll have this particular value. So we have a message type, say connect. So then value will be 1. That means client to server, there should be a request for a connection. So initially, whenever a client wanted to share the data, then client should request, saying by passing or by sending the value 1, saying that the client is requesting for a connection from the server or towards the server, and the connect CONNACK with the value 2, that is connection acknowledgement, that is reply from the server towards the client with an acknowledgement. So this has been sent when the server identifies the particular client, and it will provide with the client ID so that the client can continue with its communication. So there is an acknowledgement. Yes, you are identified. Please proceed. Third one, that is message type is publish. With respect to publish, it is a publish message from client to server. The flow might be client to server or server to client. It is just a publish message. So we'll see an example with this. Say, for example, with respect to client, MQTT client, it may read the temperature value, sent to the MQTT server or message broker. So that is publish message. And on the other hand, server acknowledge the particular message reception in the server end. That is again publish message. Then we have public acknowledgement with the value 4. That is client to server or server to client. Whatever it is published in the previous stage, that is should be acknowledged with the value 4. Then whenever that published message is received, we must send a value PUBREC with the value 5, that is client to server or server to client. The meaning is publishing is received, as we have publish and subscriber. Then PUB release, publish release with the value 6, that is again client to server and server to client. Then publish complete. So this one supposed to highlight with this one PUBCOMP, saying that at a time one particular client as a subscriber, it may request only one particular data. So we took an example of temperature data and humidity. So during a particular time, a particular client needs only temperature data. Once that temperature data is received, then the particular application or client may request for humidity data. So at that time, there should be a switch between different data. So this switching can happen only when uh, the message type, which is having the value 7, that is publish complete. So that we are acknowledging on from the other side or from the both side, we are going to switch over between the different data. Then subscribe, client to server, subscribe request. So here one thing supposed to remember. So first connect, the first value, that is connect, client to server, that is initial request to connect. So this one is subscribe request. Please note the difference. This is a subscribe request with the value 8. And with the value 9, it is a subscribe acknowledgement. So once it is over, you can send unsubscribe with the value 10. It is from client to server. Then unsub, that is unsubscription, acknowledged from the server side. So now, after all this, we know, so how to check the connection, whether connection is proper between client and server by sending a ping message. So that is ping request can be sent from client to server using PING ping request with the value 12. And for that particular request, server should respond to the client, that is with the ping response. And then disconnect, there is client to server. Once everything is over, all the data has been sent from the MQTT client towards server, then MQTT client may say, by saying disconnect message type, the client can disconnect with the connection. So that is different 14 types of MQTT messages, which is to be set in this particular field. Please check it out. This particular field, message type will be having 14 types. So these are the 14 types we discussed just now. Moving further, we have QoS field over here. So this particular QoS field is again of 3 levels. We have 3 levels: QoS 0, QoS 1, QoS 2. So QoS 0, it is a best effort and once at a time, only once, and it is unacknowledged data service, referred to as at most once delivery. So with respect to this, if we set up QoS 0 in that particular field, saying that only once we are sending the data, either from client or from the server, saying that only once I will be sending this particular data. If you want, you can catch, otherwise leave it. I won't guarantee. That is how it works. So that is only once, with the full effort, full strength, full bandwidth, they are sending the data. That is QoS 0. And QoS 1, which ensures message delivery with an acknowledgement, either from either between publisher and server, and then between server and subscriber, occurs at least once. So QoS 1, please come back to the previous diagram. QoS 1, that is, there is an acknowledgement saying from the both end. So this part, please follow the diagram, please follow my cursor as well. So MQTT client sends a data with QoS level over here 1, has set up QoS level 1. So what happens is, whatever the data sent to server from this point to this point, that is acknowledged, and whatever the data sent from this point to this point, that is also acknowledged. So this throughout, from left to right, entire thing must be communicated. Must be communicated. I'm highlighting the word must be communicated because there should be a acknowledgement, or there should be a clear-cut delivery of the message from this particular publisher to subscriber. That is what this QoS 1 says. It ensures the message delivery between sub-publisher and server, then between server and subscribers occurs at least once. Then QoS 2, that is highest QoS level, that is topmost priority. It is used when neither loss nor duplication of messages is acceptable. So saying that, when I say, or when we say QoS 2, coming back to this one, QoS field is set to 2, we are justifying in such a way that it must be the top priority, and we are sending that particular data with utmost priority, utmost quality. There should be no loss in, not at all a single loss should happen, single loss of packet should happen during the transmission, and duplication of messages not at all acceptable. I don't have space for duplicate messages. That is what this particular field will do. QoS 2, that's why it is highest QoS level. So what will happen in this, with this, it is increased overhead. With that increased overhead, because each and every time each individual packet should be justified for this, because there should not be any loss in the packet, because it must be a lossless connection. and there should not be any duplication messages. On the other hand, we can say it provides a guaranteed service and exactly once delivery with no consideration for the number of retries. So they can keep on trying either from client to server or from server to client. They'll keep on trying, but they'll send and receive the acknowledgement only once with the top priority, guaranteed service. So that is what these QoS levels will do. So we have 3 levels, QoS 0. So only once we are sending the data without acknowledgement, we are not at all worrying about acknowledgement. The sender is not at all worrying about acknowledgement and is not at all guaranteeing about the delivery also. So we'll just keep on sending message. That's it. QoS 1, it ensures point to point message transmission and reception, and it ensures the delivery from the sender till the receiver, in between with the message broker as well, throughout a continuity from top to bottom. That is QoS 1. QoS 2, that is topmost quality. So there should not be any loss. There is no loss and no duplicate packets. So it will provide guaranteed service and only once with the acknowledgements. That is QoS levels. We'll see an example over here. So in this diagram, we have different QoS levels. QoS 0 at most once delivery, QoS 1 at least once delivery, QoS 2 exactly once delivery. So we are differentiating with the QoS, quality of service. So publisher can send or receive the messages by highlighting QoS 0 in that particular field, MQTT data format field. So that is, if it is QoS 0, that is at most once, without worrying about acknowledgement and without worrying the transmission. QoS 1, at least once it should be delivered from publisher to subscriber, end-to-end connection, justified connection, sure connection, authenticated connection from subscriber to publisher. Please follow my cursor as well. So that's why I'm highlighting over here throughout this end-to-end justified connection. And over here also QoS 2, it is again justified connection, and they are trying, keep on trying for a successful transmission and reception, but the receiver receives the message only once and it should be guaranteed. So that is what the difference between different MQTT QoS levels. So I guess you cleared with this particular concept. So we'll see the difference between the major two competitors with CoAP and MQTT. So the main transport protocol with CoAP is UDP, MQTT is TCP. The transport protocol that we establish in MQTT is TCP and CoAP is UDP. Hence, MQTT will have higher weightage because it is connection oriented service. As we have different QoS levels, we can justify our communication channel as well because it is purely circuit switched or connection oriented setup. CoAP, there may be a loss because there is not guarantee and more time consuming, more delay may happen using this one. With CoAP, we have a typical messaging concept, that is request and response. With respect to MQTT, it is publish, subscribe methodology has been implemented. And effectiveness, it is excellent. CoAP with the excellent with the low level networks. Coming to the MQTT, so when compared with the UDP, MQTTs are a little bit better, but it's fair. We can't say, we can't justify in such a way that everything is guaranteed. So low or fair effectiveness. Security is concerned with MQTT follows SSL, secure service layer, or TLS. With respect to CoAP, it is DTLS. Communication model with the CoAP, it is one-to-one. and MQTT is many to many. So this is one of the major advantage with MQTT. So it is many to many, many number of clients as publishers. On the other end, many number of clients as a subscribers. In between, we have message broker or server to look after all these. That's why many to many. So if you have n number of sensors in your tiny device connected, and on the other end, if you have n number of applications or user interfaces, n number of users may be watching all over those sensor data. So it can be happen only with respect to MQTT. And the major strength in COAP are it is lightweight, fast, less overhead. It is much suitable with our constrained network. It uses a lightweight RESTful model, easy to code, easy to parse, easy to process. Multicasting is supported. Both asynchronous and synchronous messaging can be happened with the continuity with the sync bits. Coming to MQTT strengths, we have TCP as a major hand and multiple QoS options, so that we will have robust communication between publisher to subscriber or from client to server, from again to subscriber on the other side as well. It is very easy to manage, simple management and scalability using a broker architecture. Only thing is broker should be a strong, server should be strong enough to handle all those subscribers and publishers. N number of publishers and n number of subscribers can be handled via using a message broker or on the main server. Then major weakness is with respect to COAP, it is not reliable as TCP based MQTT when compared with that. Because when we compare with the TCP, TCP will be in the upper hand, will be an upper hand because there is a there may be a stronger end-to-end connection is established with respect to TCP, and UDPs as it is connectionless protocol, we are not guarantee as there is a reliable connection establishment. And coming to the MQTT, the major weakness is overhead, higher overhead because of the QoS levels and the number of networks or type of network that we use in that different layers. And TCP, when we say TCP connection, that is guaranteed connection, it may drain low power devices. This is one of the weakness. Second weakness, low power devices can be drained because it will take constant power. It may need constant power supply because there is a there whenever when a packet should be sent from sender to receiver. On the other hand, receiver should send acknowledgement towards the sender as well. So that's why it may consume much power than COAP, and multicasting support is not there. So that is as a weakness. So this is the differences between or comparison between COAP and MQTT. So if you have any doubts, please get back to me. You can mail, you can comment on the sections. Okay, that is about the module 3. Thank you.